Welcome. Today we're going to take a deep dive into something quite interesting. There's a recent report from the Government Accountability Office, the GAO, and it was highlighted in Space News. It uncovers this, well, surprising paradox right at the heart of how we operate in space. It's pretty fascinating stuff.
Yeah, it really is. What's truly intriguing here is how some operational models can get so deeply, embedded, even in a field like space exploration, which we always think of as just constant, rapid innovation.
Right.
So we're going to explore why this really fundamental approach to satellites, it hasn't really shifted much in decades, despite all the incredible tech advances.
Okay, so let's jump right in then. You probably imagine, with all the new rockets launching, thousands of satellites going up every year, you'd think the basic way we handle spacecraft has totally changed, right?
You'd think so.
Well, according to this GAO report, that's not quite the full story.
No, it's not. And if we connect this to the bigger picture, the report that just came out yesterday, July 10th, it reveals that the fundamental operating model for spacecraft, it's still essentially the same blueprint, the one laid down way back in 1957.
1957, you mean with Sputnik?
Exactly, with Sputnik.
Wow, okay, that's a stark contrast to what I think most people would assume. So let's dig into that. What exactly is this fundamental operating model they're talking about? Why is it so sticky?
Well, it's what some people call the build it, launch it, use it, discard it approach.
Build, launch, use, discard.
Okay, it's a single-use model, and it's been pretty much unchanged for, nearly 70 years now. Because, back with Sputnik, that was really the only practical way. You built this self-contained unit, you launched it, you used it until it ran out of fuel or something broke.
Yeah.
And then it just became space junk. And that precedent, which was really born out of necessity back then, it just kind of stuck.
Okay, but here's where it gets, really interesting, right? This report points out that this traditional, almost disposable approach, it's still going on, despite the fact that we have these genuinely groundbreaking new technologies. Tech that promises to make satellites, serviceable in orbit.
Exactly.
So we actually have the tech now to potentially fix them or upgrade them right there in space, but we're still mostly just letting them die off.
That's the core of the paradox. And when we talk about in-orbit serviceability, we're not just talking hypotheticals or sci-fi anymore.
Right. This isn't theory.
No. We mean actual demonstrated capabilities.
Right.
Things like refueling satellites to make them last longer.
Okay.
Or repairing components that break, like a solar panel or an antenna.
Yeah.
Or even, upgrading their software or hardware during the mission to adapt to new requirements. The potential is there.
It just seems so counterintuitive, then, that this disposable approach keeps going, especially when we hear so much buzz about these advanced servicing capabilities. So, if the technology is clearly emerging, what are the real roadblocks? What's keeping this nearly 70-year-old model so firmly in place? Is it just cost? Or reliability worries? Or, something else entirely? What does the GAO report suggest? Or what can we kind of infer?
That's really the million-dollar question, isn't it? And the report, along with just looking at the industry, it points to a few critical things. One big hurdle is just the sheer upfront cost and, frankly, the complexity involved in developing and then consistently demonstrating these in-orbit servicing capabilities.
Okay, so proving it works reliably every time.
Exactly. And it's a bit of a chicken and egg situation, too. Without widespread demand from satellite operators for serviceability features, the investment needed to build out that servicing infrastructure is, it's harder to justify for the companies developing it.
Right. Who pays first?
Precisely.
Yeah.
And then there's the issue of standardization, or rather, the lack of it.
On the satellites themselves.
Yeah. Most spacecraft currently flying, and many still being built, they weren't designed with servicing in mind. They don't have standard grapple points or refueling ports or data interfaces. So they aren't built to be like plug and play for repairs or upgrades. That makes it incredibly difficult, sometimes impossible, for a servicing vehicle to even connect with them effectively.
So it's not just about building the repair bot, it's also about convincing satellite makers to redesign their satellites to be repairable from the get-go.
Yeah.
That makes a lot of sense.
It does. It requires a shift across the board.
Okay, what else is holding things back?
Well, beyond the purely technical challenges, there's a whole established ecosystem. The entire supply chain, from the companies manufacturing the satellites to the launch providers, it's all optimized for this disposable model. That's how they built their businesses over decades. So any shift towards a service-oriented approach where satellites last longer and maybe fewer new ones are needed, that's incredibly disruptive. And it's potentially financially risky for those established players who've, perfected the current way of doing things. It's a really big ship to turn around.
So, what does all this mean for you as someone trying to understand the big picture in space? It really highlights that even in these super high-tech, forward-thinking fields, these deeply embedded practices can be incredibly tough to change. Even when you have what look like superior, maybe more sustainable alternatives demonstrably available, it forces us to ask, okay, what are the actual real-world consequences of sticking with this disposable model?
Well, the most obvious one, the one everyone talks about, is the growing problem of space debris.
Right. All that junk floating around.
Exactly. Every satellite that's just discarded at the end of its life adds to the orbital clutter.
Yeah.
That increases the risk of collisions, which then creates even more debris.
A cascading effect.
Yeah, the Kessler syndrome idea. It threatens satellites that are still working. So that's huge. But beyond that, there are also significant cost inefficiencies, even if it doesn't seem like it at first glance.
How so? Building disposable might seem cheaper up front, right?
It might seem cheaper for a single unit, maybe, but think long term. The inability to extend missions when a satellite is still mostly functional, but just out of fuel, or the inability to upgrade its capabilities as technology improves, or to recover valuable components. It means you potentially face higher long-term costs because you constantly need to build and launch entirely new, full-fledged satellites just to replace the old ones, often before their core systems are even obsolete.
I see. And it limits flexibility too, I guess.
Definitely. A satellite's capabilities are basically locked in the moment it launches.
Yeah.
If you needs change or a better sensor comes along, too bad. With servicing, you could potentially adapt.
Okay. So we've really peeled back the layers on this fascinating paradox today. We've gone from the historical roots, this disposable satellite model, basically starting with Sputnik out of necessity, all the way to these complex economic and logistical hurdles that are now holding back genuinely revolutionary approaches like in-orbit servicing. It really underscores how deeply rooted practices can be, even in fields we think of as purely innovative, and even when powerful new technologies are clearly emerging.
It's a really powerful reminder, I think. The true innovation isn't just about inventing the cool new tool, the new tech. It's just as much about the willingness and, frankly, the infrastructure needed to actually embrace that tech and implement it widely.
So let me ask you this, and maybe something for our listeners to think about too. What really stands out to you when you consider that an entire industry, one so focused on the future, is still fundamentally operating on a blueprint that's nearly 70 years old?
That's a great question to ponder. For me, it raises this important point. What does this persistent reliance on the disposable model even now, as in-orbit serviceability is becoming technically possible? What does that tell us about the real hurdles? Are the true barriers maybe less about the technology itself and more about the deep-seated economic models, the logistical challenges, the sheer inertia in the system? It really makes you wonder if progress in space or maybe anywhere is about more than just the next big technological breakthrough. Perhaps it's just as much about overcoming those established ways of doing business, those financial incentives that keep the old models running,